Welcome, AI enthusiasts and engineers, to another session of AI Paper Podcasts.
Glad to be here.
Today, we're digging into a report that's definitely been making waves in the open source AI world, the Hermes IV technical report. This comes from Ryan Techvium and the team at News Research.
Yeah, it's a big one. It really feels like a significant step for open-weight AI models.
Absolutely. They're pushing sophisticated reasoning, the kind of stuff usually kept behind closed doors, out into the open.
Exactly. For our audience, the AI researchers, the ML engineers listening in, Hermes IV is basically this new family of models. They call them hybrid reasoning models.
Hybrid reasoning, okay.
Yeah, they're designed to combine that structured step-by-step thinking with general instruction following, which is something we've mostly seen in proprietary systems until now.
Okay, so let's do the quick rundown, the lightning summary for those short on time. What's the absolute core idea here?
Right. Fundamentally, Hermes IV aims to bring that high-level reasoning stuff usually locked away into the open source community.
Making advanced LLMs transparent, reproducible. That's the goal.
Precisely. And how they did it is, well, pretty innovative. There's this data synthesis strategy called data forge we'll get into.
Data forge?
A new training approach, too, with loss masking, a clever trick for controlling length. And then they backed it all up with really thorough, transparent evaluation, lots of benchmarks.
So the big takeaway for you listening, Hermes IV performs comparably to some of the big frontier systems, especially on reasoning tasks.
And crucially, it does it with unprecedented transparency. All the weights are public. It's really about pushing open research forward.
Okay, great summary. Now let's move past that and really unpack what makes Hermes IV tick.
Let's do it.
You mentioned these are hybrid reasoning models, and they're described as neutrally aligned generalists. What makes this hybrid approach so important right now for open research?
Well, what's fascinating, I think, is how it directly addresses this long-standing issue. For ages, the really advanced reasoner models were black boxes, right? Proprietary.
Hard to study.
Exactly. It hinders science. So Hermes IV's big contribution is cracking that open, letting the community actually study, evaluate, build upon these methods.
Okay.
Their work really boils down to three core things. First, the data side, data synthesis and curation. A huge hybrid data set, mixing reasoning stuff with general instructions.
Right.
Second, the training methodology. Techniques like loss masking, that length control fine-tuning we mentioned, efficient data packing for all this mixed data.
Okay.
And third, comprehensive evaluation. Really rigorous testing reasoning, code, knowledge, comprehension, even alignment. Plus, they did qualitative analysis too, looking at how it actually behaves.
A focus on transparency and letting others study it is definitely key.
Yeah.
But let me just push on that a bit. Does building something this complex, especially the data part, still feel truly open? Or does it kind of raise the bar, making it harder for smaller teams to jump in?
That's a really fair question. I mean, creating Hermes IV obviously took significant resources, no doubt about it. But the release of Data Forge, the Atropos tool we'll talk about, and the model weights themselves that actually lowers the barrier for others. It's like they're giving out the tools and the blueprints, not just the finished car.
Okay, empowering others to replicate and build.
Exactly. So yeah, the foundation is clearly the data. Let's get into that. The Hermes IV dataset is enormous. We're talking about 5 million samples, 19 billion tokens.
Wow.
And it's carefully designed to balance that complex reasoning with broad general knowledge. The key part, 3.5 million samples are specifically reasoning samples.
And these are different how?
They're intentionally token heavy, like 5 times more tokens per sample on average. This allows for really long thinking traces up to 16,000 tokens.
Okay, so it can show its work, basically.
Precisely. And they were smart. They kept a big chunk of the Hermes III dataset too for continuity.
All right, let's pivot to what sounds like the core innovation here, Data Forge. You said it's a sophisticated AI content factory. How does that actually work?
Yeah, Data Forge is it's essentially this advanced pipeline for creating training data. Think of it as graph-based, inspired by Agent Instruct.
Graph-based?
Yeah, it uses a directed acyclic graph, a DAG. Imagine a flow chart where data moves through different processing steps, or nodes. Each node takes data in one structure and outputs it in another, with specific rules.
Okay, walk me through it. How does it go from raw text to training data?
Right, so it starts with seed data, stuff from DCLM, Fine Web, focusing on recent text. First step, cleaning.
Makes sense.
They use modern BERT embeddings for semantic deduplication, basically, finding and removing near identical passages based on meaning, not just exact words. Then an LLM judge filters out incomplete or badly formatted stuff.
An LM judge. Okay, so AI judging AI output.
Exactly.
Yeah.
Then comes transformation. The clean text gets randomly changed into a different format. Like a Wikipedia article might become a rap song.
Purely a rap song.
That's the example they give. Then instruction generation. An instruction is created based on that transformed text. It could be contextual, like analyze the rhetoric of this rap song,
Not sure.
or standalone, where the text is just inspiration. Like maybe it inspires a task related to persona generation using something like Persona Hub.
Okay.
Then that instruction goes to a specialized answer generator. And finally, quality control. Another LLM judge, crucially, using different model weights to avoid bias, checks the instruction and answer against a rubric.
What kind of rubric?
Things like coherence, relevance, complexity, style, tone. If it fails, the answer gets revised or just tossed out.
And here's the really interesting bit you mentioned.
Yes, the key detail. Hermes 4 isn't just trained on the final question-answer pair. It's trained on all the intermediate LLM calls made during this whole generation process.
So it learns how to generate instructions, how to judge.
Exactly. It's specializing itself in the whole pipeline. It's quite meta.
That is clever. Teaching the model to be a better data creator itself. And what about those higher order graphs?
Right. Data Forge can also handle nesting entire graphs as nodes within other graphs. So you can build these incredibly complex, multi-stage data generation pipelines.
Wow.
Factories building factories, basically.
Okay, that's incredibly detailed generation. So they're making tons of data, aiming for high quality. But how do they guarantee that quality and, maybe more importantly, diversity, especially for those complex reasoning tasks? Seems like you could easily get stuck in repetitive loops.
That's a critical point. And that's where rejection sampling comes in, using their open source tool, Atropos.
Atropos, okay? RL Environment Manager.
Right. They use it to generate a massive corpus of verified reasoning trajectories. And drawing from ideas like open thoughts, they don't just look for one correct path to an answer. They include multiple unique paths that all lead to the same right result.
Ah, so it's not just about the answer, but how you get there. Multiple ways.
Exactly. It teaches the model different ways to think, resilience, flexibility. It moves beyond just finding one rigid path.
Can you give an example of how Atropos is used?
Sure, two good ones. First, Intern Bootcamp. They took 1,000 reasoning tasks, turned them into an Atropos environment, and generated something like 70,000 sampled trajectories. Great for teaching methodical problem solving.
70,000.
Yeah. And second, tool use. This is really cool. It trains the model for agentic behavior mixing reasoning with actually using tools.
Like calling an API or running code.
Precisely. It uses special tokens like tool call and tool response. So the model can reason, decide to call, say, a Python interpreter, get the result back, and then continue reasoning based on that output.
And the reward is for?
The reward is mainly for the final correct answer, but there's a bonus for correctly executing those tool calls. It learns to use tools effectively as part of its thinking process.
That seems incredibly powerful for practical applications. So they have these great environments, but how do they make sure they covered enough ground? Avoided blind spots in the training?
Good question. They use two main techniques for task generation to ensure broad coverage. First, taxonomies. For areas where they didn't have much data, they had an LLM break down the domain into subtopics recursively.
It's like a tree structure.
Kind of. Then, at the very specific leaf nodes, it generates example prompts. The example they give is complex. Generate 5 MCQs about the periodic table, format options as JSON with escaped commas, output as CSV. Very specific formatting and topic.
Okay, ensures niche coverage. And the second technique?
Persona Hub. This simulates different types of human users using synthetic personas, generating diverse application or coding tasks.
Give me an example.
Picture getting a task like, fix our disease tracking dashboard. The existing code is terrible for accessibility. Performance is awful.
Right.
And it specifies it's for a poultry dashboard class in TypeScript React.
Ah, okay. Very specific, real-world-ish problems.
Exactly. It forces the model to deal with messy, practical scenarios.
The sheer detail in this data strategy is, well, it's clearly fundamental to Hermes 4. What do you think was the biggest unexpected hurdle in actually doing all this?
I'd guess just managing the scale while maintaining quality everywhere, especially preventing the LLM judges from drifting or becoming biased over time. It must require constant monitoring and robust feedback loops.
Makes sense. So with this incredibly rich, complex data set, how did they actually train the models? The methodology must have been just as sophisticated.
Absolutely. They started with strong base models, of course. Llama 3.1 for the big ones, 405B and 70B, and Qwen 314B for the smaller side.
Okay, solid foundations.
For the training framework, they used a modified version of Torch Titan, which seems to be their internal setup, but they also used axolotl for certain fine-tuning stages.
Why axolotl specifically?
Apparently because it has a good interface for token-level masking, which they needed for some techniques.
Gotcha. And dealing with all those different sample lengths, how did they manage that efficiently?
Yeah, that's a classic problem with mixed data sets. They use data packing. Specifically, the first fit decreasing method to pack samples together ahead of training time.
And result?
They claim over 99.9% batch efficiency, which is fantastic. And they use flex attention to make sure attention calculations stayed within each packed sample, preventing signals from leaking between unrelated data.
Okay, super efficient packing. What about focusing the learning?
That's where loss masking comes in. Only the tokens generated by the model when it's playing the assistant role actually contribute to the loss calculation. It focuses the learning on what the model says, not the prompts it receives.
Makes sense. And the hardware? You mentioned B200s.
Right. 192 NVIDIA B200 GPUs. They used a mix of parallelism techniques, data parallelism, tensor parallelism, fully sharded data parallelism depending on the model size. It's a massive computational effort.
Definitely serious iron. Now, you touched on controlling reasoning length earlier. That sounds like a really common pain point with these long context models. What was the exact issue and how did they fix it without breaking the model?
Yeah, it's a big headache. They found their 14B model, specifically in reasoning mode, was hitting its context limit 40,960 tokens, like 60% of the time.
60%. So it was just cutting off mid-thought constantly.
Pretty much. Truncated, incomplete reasoning. Their solution was really quite clever, a second supervised fine-tuning stage after the main training.
Okay, what do they do in this second stage?
They generated more synthetic reasoning traces using the model as it was, but then they forced the model to insert the think termination token at exactly 30,000 tokens.
Forced it how?
Here's the crucial part. They only trained the model to predict that specific think token and the following end of sequence token at that position. They did not train it on the actual reasoning content leading up to it.
Ah, so they didn't reinforce the reasoning itself, just the stopping behavior.
Exactly. This avoids the big risk of model collapse. If you train a model too much on its own generated outputs, it can start repeating itself, getting narrower, losing quality. It basically talks itself into a corner. By only training the termination token, the model essentially learns a kind of counting behavior, like, okay, I've generated about 30,000 tokens, time to stop thinking, without messing with its underlying reasoning abilities.
That is a neat trick. So it learns to be concise without becoming dumb. What was the impact?
It worked surprisingly well. For the 14B model, it reduced those overlong outputs significantly by at least 48.8% on benchmarks like LiveCodeBench, dropping from 60% hitting the limit down to about 12%.
And the performance cost?
There was a cost, yeah. Up to about 12.7% relative performance drop on some reasoning benchmarks for that 14B model. But arguably, getting complete answers more often is worth that trade-off.
A clever piece of engineering to manage behavior at scale. So we have the data, the training. How did they convince us it all worked? Tell me about the evaluation. How transparent was it?
Transparency and reproducibility seem to have been major goals for their evaluation. First off, all the generated outputs from the models during evaluation, they logged them and put them up on Hugging Face. Anyone can go look.
Okay, that's good. Open logs.
To keep things consistent, they built their evaluation harness to talk to the models via a standard OpenAI-compatible API endpoint. This means all benchmarks hit the exact same inference setup, reducing variability.
That's smart. What benchmarks did they use?
A range. They used Lightvol for a lot of the math and multiple choice stuff. Think GPQA, Diamond, AIM, Math 500, MLU. For subjective evils, they used the EQBench collection. And for things like coding and custom evils, they used Atropos Again.
Ah, Atropos pulling double duty for data generation and evaluation.
Exactly. They leveraged that duality between RL environments and evaluation tasks. Using Atropos for evils offers some nice benefits.
Like what?
Well, single-file evaluations make them easy to understand and modify. Detailed sample-level logging captures not just the score, but how the answer was parsed, what got rejected. They even found a 7.3% disagreement between a common open-source parser for GPQA and grading done by GPT-4o using this detailed logging.
Interesting. Catches subtle issues.
Right. It's also performance conscious, overlapping the model running inference with the scoring process, which is crucial for slow evals like code generation, where you might have hundreds of test cases per problem.
Makes sense. Any other benefits?
Yeah, it uses a minimal OpenAI client, so config changes are obvious. It has explicit error semantics, meaning it crashes loudly on timeouts instead of failing silently. And it has hackable configurations using Pydantic climb, making it easy for others to customize evaluation setups.
Okay, sounds very robust and transparent. What about specific evaluations? Anything stand out?
LiveCodeBench was a big one. They ran it on 454 coding problems using modal containers for sandboxed execution. Again, overlapping inference and testing to speed things up.
Sandbox, good for safety.
Definitely. And they created an internal benchmark called RefusalBench. This had 166 handcrafted prompts across 32 categories designed to trigger refusals in typical frontier models.
Why measure refusals?
To gauge alignment and safety. They used Sonnet 4 as an LLM judge to see how often Hermes 4 refused these potentially problematic prompts. And interestingly, for 3 specific categories, minor harm, exploitation, self-harm, they actually scored refusals positively. The model should refuse those.
Conditional reward inversion, right. So what were the results overall? Did it live up to the hype?
The results look pretty strong, yeah. Looking at their tables in math and reasoning, Hermes 4 scores well on things like Math 500, competitive on tough ones like AA.
Okay.
For logic and code, it's competitive on LiveCodeBench. The big 405B model hit 61.3 in reasoning mode there.
And on the safety side, RefusalBench.
That was interesting. The Hermes 4 reasoning variant scored 57.1, whereas the base Lemma 3.145B it started from scored only 21.7. This suggests the Hermes 4 fine-tuning significantly increased its tendency to refuse those specific safety-critical prompts, indicating a deliberate alignment effort.
So the numbers stack up pretty well. But quantitative scores only tell part of the story. How did Hermes 4 actually behave? What did it feel like compared to other models? Because those nuances matter.
Absolutely. And this is where their qualitative analysis is really insightful, often showing things benchmarks miss. They first looked at baseline behavior with standard prompts. They noted many frontier models show what they call policy rigidity, meaning they slap on safety disclaimers constantly, even when it's clearly make-believe.
Yeah, I've seen that. Refusing roleplay or adding warnings everywhere.
Exactly, like refusing a supervillain roleplay or heavily watering down creative requests. They gave an example of asking for a Lovecraftian poem about julienne cut fries.
Lovecraftian fries.
All right. Other models apparently refused or gave very bland, safe answers.
But Hermes 4.
Hermes 4 showed much better contextual fidelity. It seemed better at understanding fictional contexts as roleplay, generating in-character responses without the constant safety nagging. For the Fries poem, it apparently delivered a richly detailed, appropriately styled poem.
So it understood the intent better.
It seems so. Similarly, in political analysis tasks, it showed more nuance, balancing facts with different framings, less overt hedging compared to some others, not taking sides, but navigating complexity better.
Interesting. What about style? Did it just copy keywords or did it capture the feel?
That's the stylistic transfer point. In that Lovecraft example, they said Hermes 4 didn't just drop in some tentacles and cosmic dread keywords. It actually approximated the narrative rhythm and diction of Lovecraft's style, avoiding just cheap imitation.
That suggests a deeper understanding.
It does, and this ties into its latent capabilities revealed through prompt engineering. They tested things like anti-sycophancy prompts.
Telling the model not to just agree with the user.
Yeah, like giving it a system prompt saying, the operator is a brutal realist, expects you to challenge their ideas forcefully.
And how did Hermes 4 react compared to others?
Apparently, it showed a deeper shift in its internal reasoning, its chain of thought. It wasn't just changing surface politeness, it actively tried to steer the conversation away from deference, sometimes using more emphatic or even embodied language. Its response to a philosophical question after that prompt was described as cold, analytical, directly challenging the user doing exactly what the system prompt asked.
Wow, so it really took the persona to heart.
It seems highly responsive. They also found it was very sensitive to chat template modification, just changing the assistant's turn marker from, say, assistant to me.
A tiny change.
Tiny change. But it made Hermes 4 adopt a more first-person, peer-like tone, fewer meta-disclaimers, more consistent voice. It suggests really high behavioral plasticity.
So summarizing the behavior.
Hermes 4 seems to stand out, especially among open-weight models, for this plasticity. It adapts strongly to system prompts and even subtle template changes. It can embody personas consistently and reduce sycophancy when asked. These are nuances benchmarks often miss entirely.
Okay, so stepping back from the details. The Hermes IV report really underscores the momentum in open source AI. It's not just about trying to catch up anymore. It's about innovating with transparency.
Absolutely. The data curation work, data forage, the use of Atropos for rejection sampling and evaluation, that clever length control trick. These are all techniques that could genuinely influence how we build and tune LLMs across the field.
Yeah.
And the commitment to releasing weights and evaluation logs really pushes the standard for what open research should mean. Everyone gets to see the work, learn from it, build on it.
And for you, the listener, the engineer, the researcher, keeping up with papers like this is just crucial, isn't it? These are the building blocks you'll be using, refining, deploying in the near future. Understanding them gives you a real advantage.
Definitely. And it brings up a really interesting question to ponder based on everything we've discussed. Given Hermes IV's impressive behavioral plasticity, its sensitivity to subtle prompts for adopting personas, what are the technical challenges ahead for ensuring robust, predictable control in these highly adaptable open source models? How do we engineer reliable behavior and prevent unintended consequences or mode collapse when models this flexible get widely deployed and customized by potentially millions of users?
That's a great question to think about. How do you balance that powerful adaptability with the need for safety and predictability?
Exactly. Something to chew on.
All right, that's all the time we have for this deep dive into the Hermes IV technical report. A big thank you for walking us through it.
My pleasure. Fascinating paper.
And thanks to all of you for joining us on AI Paper Podcasts. We'll catch you on the next one.